Okay, so chapter 6 is the uniform circular motions. Now we're going to look at circular motions, but before that, what is the important thing in this chapter? First of all, you have to know the variable that you're going to use in this chapter. So first one, we have now let's say we have a circle, and then your object is moving from these initial positions until these final positions. Okay, I'm going to call it A, and then move to B. Then the first variable, the new variables that we have in this chapter is theta, where theta, it should be in terms of radian, okay, not degree. So that is the things that you have to know. And this is our angular displacement. We look at the angles, and then what is the angles between initials and final positions. Okay, whereas when you talk about distance, you are talking about the arcs of the circle. Okay, so if you look at the distance, then from A to B, the arc of the circle, that is our distance S. Okay, so you have to know what is the difference between these two variables and how to link them together. So S is obviously equals to R theta, where R is the radius of the circle. So from this angular displacement, so theta known as angular displacement, from angular displacement, we can then calculate the angular velocity. Okay, so where we have omega equals to change in angular displacement over the change in the time. Okay, and of course, since you are looking at the angular, and of course you have something called linear velocity. So from angular to linear, what are we going to do again? So we are going to link them again by using R, okay, which is V equals to R omega. So this is very important. We are going to use these equations quite often in chapter 6. Okay, how to convert from angular speed into linear speed, or how to convert from linear speed to angular speed. So they are interchangeables, and you have to know how to convert from one to the other one, how to transform from one to the other one. And of course, the most important thing in this chapter now, since you're looking at the circular motions, then we need a new terms called centripetal accelerations, which is AC. So AC, according to its definition, is V squared over R, and then based on the relationship V equals to R omega, it can then be expanded into R omega squared. All right. So from angular displacement, we obtain angular velocity. From angular velocity, we then obtain centripetal accelerations. And of course, the most important things, we want to identify the force that causes our object to move in circular motion. Okay, so the force that causes our object to move in the circular motions, again, we are going to apply Newton's second law, which is summations F. But just as summations F, in this chapter, we don't call it net force anymore. We call it centripetal force FC. So FC equals to MA, but now this A is no longer the linear acceleration, but it is centripetal acceleration. Okay, so if you substitute V squared over R into the equations, we can then obtain mv squared over r. So this is a summary of chapter 6, the things that we have in chapter 6, the things that you have to know in chapter 6. Okay, and obviously mv squared over r can also be written as mr omega squared. All right, so basically these are the equations that we're going to use in this chapter. Now let's proceed to questions number 1. Questions number 1, if you look at the key terms, okay, what is the keywords? So the Earth is rotating about its axis. What is the angular speed in terms of radian per second? So for angular speed, the SI unit is radian per second. Okay, and of course you will see a lot of difference unit after this. So for instance, we have RPS, revolutions per second, and now we have RPM, revolutions per minute. So the SI unit should be rate per second. So this is the SI unit. Okay, and then the last one we have rate per minute. Okay, so the only terms that we want to use in our calculation is radian per second. So you have to know how to do unit conversions from all the other 3 into radian per second. Okay, from RPS, RPM, and then rate per minute into radian per second. So all this you have to know. If you don't know how to do the unit conversions, then basically you cannot solve this the questions in this chapter. Okay, now Earth is rotating about the axis, but if you look at these questions, no information is given, right? There's nothing about the Earth, so it doesn't give you any values. But then, if you know how the Earth orbits, okay, rotates, then you should have all the general knowledge already. So what is the angular speed? Now try to recall what is the equations for angular speed. Well, we need theta, and then we need time. Okay, because omega is equals to theta over time. So try to identify, do we have theta? Now, theta is angular displacement. Okay, theta is angular displacement. Try to think what happens to Earth. Okay, if Earth rotate one revolutions, then what do we have? We have a 360 degree, which is then also equals to 2 pi radian. So this is one rotation. Okay, one rotation. Or we say one revolutions, one cycle. So one rotation is equals to 2 pi radian. And then how about the time? Well, try to think, okay, this is a general knowledge. How long does it take for the Earth to rotate one round, to rotate one cycle? So that is time, it is equals to capital letter T, because now we are looking at, okay, we are looking at the time taken to complete one rotation, one revolutions. So time taken to complete one revolution for the Earth is 24 hours. And of course, 24 hours is not SI unit. What are you going to do next? You need to change it into second. So how to convert from hours to second? Now try to ask yourself, 1 hour equals to how many minutes? Well, 60. 60 minutes, 1 minute equals to how many seconds? 60 seconds. So from here, you can then calculate the total times taken for it to rotate one round in terms of a second. So if you got it correct, you should get x6400 second. Okay, x6400 second. So now that you have enough information, let's calculate the angular speed. Omega equals to theta over t, which is then equals to 2 pi. Okay, because you need the quantity in terms of radian. So over x6400, which is then equals to 7.3 times 10 to the power of negative 5 radian per second. So even though there's no information given in the questions, but we can solve it based on our general knowledge, our common sense. Okay, because now we have the object, which is the Earth. So Earth, it takes 24 hours to rotate 1 second. That is what we have been learning since primary school. All right. So the reasons why I use capital letter T here, because I'm looking at the time taken to complete one revolution. Okay, one revolutions. So capital letter T, we only use it for one condition, for one situation, which is the time taken for a complete. Okay, one complete, which is 360 degree rotation. Okay, so that is our questions 1. So now I give you 2 minutes to write down the answer and also the summary on the right hand side. Okay, try to write it down in terms of your own words in a way that you can understand. Okay, so 2 minutes for you to write it down, and then we will continue with questions number 2. Okay, so next, let's look at the questions number 2. Okay, questions number 2 is quite simple. So the exercise 1 basically is just the introductions part. Okay, that want to test whether you understand the concepts of angular speed, angular displacement, whether you know how to do unit conversions or not. So a car travels around circular path of a circle of radius 5 meters. At a rate now, you see, you got a unit in terms of rev per minute, which mean revolutions per minute. Okay, so find its angular speed in terms of radian per second. So it wants you to find the angular speed in terms of SI unit, but given in terms of revolutions per minute. So omega given is 60 rev per minute. How to do unit conversion? Well, it is always a good idea when you have a unit that involves -1. Okay, it is always a good idea to convert it into a fraction form. So 60 rev per minute equals to 60 rev divided by 1 minute. Okay, divided by 1 minute. So now try to recall the things that we just discussed. We know one revolution is equals to 360 degree, right? And then one revolutions at the same time is equals to 2 pi radian. So what we want to do, we want to find out 60 revolutions is equivalent to how many radian. And then also we know that 1 minute is equals to 60 seconds. So that is the things that we want to substitute into our equations. So 60 revolutions, 1 revolution equals to 2 pi radian. 60 rev equals to 60 times 2 pi. So you will obtain the unit in terms of radian divided by 1 times, now 1 minute is 60 seconds, so 1 times 60. Okay, so eventually you're going to obtain 2 pi radian per second. So that is the angular speed in terms of radian per second. Okay, next, what is the linear speed then? So you have angular speed, now you want to find linear speed, which is V. V and omega, what can we do to link them together? You have only one equation, which is V equals to R omega. All right, which is then equals to, well, R given is 5, and then the omega is 2 pi. So we have a 10 pi, which is then equals to 31.42 meter per second. All right, so that is how you solve it. It's not hard, it's quite simple. As long as you pay attention to the units that you use in your calculation. Okay, especially in terms of angular speed and angular velocity. Because quite often the questions will give you the unit not in terms of SI unit. You need to do the unit conversion. Okay, so 1 minute for you to write it down before we proceed to next questions. So if you have any questions, you may ask. Okay, so questions number 2. So how are we going to solve questions number 2? So again, okay, let's try to extract the information first. So you have 2 sub questions in questions number 3. Sorry. So an object undergoes circular motions with uniform angular speed of 100 now RPM. So RPM also means rev per minute. Okay, also represents revolutions per minute. Okay, so you have to be familiar with all these terms given. So what's the questions wants you to calculate period. How to calculate period? So you try to think, what is the relationship between period and speed or angular speed? Okay, so givens t is equals to 2 pi omega. Okay, so we need the values of omega, but now we want it in terms of SI unit. So omega given is in terms of RPM. So again, what are we going to do? We change it into fraction form, which is 100 rev over 1 minute, which is then equals to 100 times 2 pi divided by 1 times 60 seconds. Okay, then you obtain 10.47 radian per second. So now you have it in terms of SI unit. You can then sub it into the first equations. So T equals to 2 pi over 10.47, which is then equals to 0.6 second. Now, sometimes students will ask me, can you leave omega in terms of pi? Of course you can. Okay, so for example, now these questions, if I want to leave it in terms of pi, so what am I going to do? So this is 3, this is 1. So I will have 10 over 3 pi radian per second. Then you sub 10 over 3 pi radian per second into the first equation. Also can, okay, nothing's wrong. All right, you can leave it in terms of pi. Now, if you don't want to leave it in terms of pi, actually to be more precise, I should leave the answer in terms of 4 decimal places. All right, so before you reach final step, you leave everything in 4 decimal places. And then final step, you round it up to becomes 2 decimal places. So in exam, usually that is what we do. Okay, step 1, diagram and equation. Okay, so step 2, substitution. And then step 3, you solve it. Okay, and then step number 4, we make sure we have a correct answer plus unit. So from step number 1 until step number 3, we leave our answer in terms of 4 decimal places. Okay, just the final step, you round up to becomes 2 decimal places. Okay, of course, this is for a small value. If you have a very large value, for example, you have the value that is already up to maybe 200, 300, or even 1,000, then you don't need to keep any decimal places. Okay, you just make sure you have 3 significant figures in your final answer if you have a very, very large value. All right. So this is how you solve it. All right. This is how you solve a question number 3A. So question number 3B, you want to find frequency. So T is equals to 0.6 second. And we know that T is equals to 1 over F. So which is then equals to, okay, F is equals to 1 over T, which is 1 over 0.6. So the answer should be 1.67 as negative 1. Okay, 1.67 as negative 1. Now, of course, you can write it in terms of hertz. Just that hertz is not well, I would say it's not that nice to use it. Why? Because now you're looking at a period in terms of second. Okay, and this is a base SI unit. Okay, so if you want to write it in terms of hertz, also can. That is fine. Okay, just that try to get used to the base SI unit. Okay, so you have S negative 1. So that is your questions number 3. Again, 1 minute for you. Right. So this is still a very simple questions. Okay, just play with unit conversions. Now, these questions is a slightly more complicated. Why? Because it tests your concept. Okay, they're betul-betul test concept and see whether you understand what is the difference between scalar and vector or not. So a particle moves in a semicircular path AB of radius 5 meter with constant speed of 11 meter per second. So you have radius 5 meter, you have speed 11 meter per second as shown in figure above. Calculate the times taken, okay, and then the average velocity and also the average accelerations to travel from A to B. So how to solve these questions? Now I'm going to label them as questions A, questions B, and question C, okay, to make it easier for me to address the questions. Questions A, you want to calculate the time taken. How? Okay, so that would be the questions. How are we going to calculate the time taken? So we know that, okay, A, we are given V is equals to 11 meter per second. So this V, if you look at the questions carefully, it is speed. Okay, it is speed. So if you want to calculate speed, okay, the equations we are going to use is v equals to changes in s over changes in time. All right. So this s, now if you are looking at speed, then what does it mean? This s is actually the distance. Aha, why is it so important to know whether it is distance or displacement? Because distance, it is the total path traveled. Okay, distance is the total path traveled. So which means what are you going to do is you want to calculate the path traveled by this object, which is the arc of the semicircle. Okay, the length of this semicircle. So this is our S. So how to calculate S? Now, if you look at the questions, okay, what we know is now it travels by half circle. Half circle means your theta is now equals to pi radian. Because one cycle is 2 pi radian, so half cycle theta is equals to pi radian. Okay, so what we want now is S. So S equals to r theta, okay, which is then equals to 5 times pi, which is 15.71 meter. So that is the path traveled by object from A to B. Okay, so that is the half of the perimeter. So now that I have S, I can then calculate the time taken. So V is 11, and then it travels by 15.71. So we want to find out what is the time. So rearrange the equations. You're going to obtain t equals to 1.43 seconds. All right. So your v given is speed. So if you want to calculate speed, you use distance divided by time. That is the first thing. So now let's look at second questions. Second questions, you want average velocity. Okay, average velocity. Now you're looking at the terms. Okay, just now we have speed. Now you want the terms velocity. So what happens in the second questions? Questions B. Okay, questions B. Now we're still looking at V. Okay, V average, but it is S final minus S initial over T final minus T initial. But then, if you're looking at velocity, then what does it mean is your S, it should be displacement. Aha. Now you need displacement. So what is the difference between distance and displacement? So you recall the equations, the definitions that I give you just now. Distance is the total path traveled. When it comes to displacement, okay, when it comes to displacement, you don't care about the path. What you want is just the shortest distance between initial and final. Okay, shortest distance between initial and final. So that is what we want. So if you look at the diagram, now my initial position is point A, my final position is point B. The shortest distance between them, which is a straight line, is now the radius of the circle. Okay, so this is the shortest distance. It's no longer the blue color path. Now you're looking at the yellow color path. So the highlighted path, that is the displacement. Okay, so which means in order to calculate average velocity, we use S final is equals to 10 meter. All right, is equals to 10 meter because the shortest distance between A and B is 10 meter. It's a linear line, it's a straight line. So 10 minus 0 over the time. Time is still 1.43. It doesn't matter whether you're looking at distance or displacement. As long as the initial and the final, they are the same, then the time should be the same. Okay, so minus 0, which is then equals to, now what do I have? I have an, the value should be 6.99 meter per second. Okay, 6.99 meter per second. And it says to the right. Why? Because now your displacement is going to the right. Okay, your object is going to the right. So average velocity, now you just write 6.99 meter per second. Okay, it's enough. Okay, so average, now we have average 6.99. So next, okay, next we want to look at average accelerations. So how to calculate average accelerations? A average is then equals to V final minus V initial over T final minus T initial. Okay, accelerations, you're looking at velocity. But if you look at the questions, okay, if you look at the questions, again, what happened is that now your object is moving with constant speed throughout the semicircle. So it doesn't matter which one you're looking at, the velocity is always equals to 11 meter per second. The only things that you have to be careful, because now you're looking at velocity, okay, you're looking at velocity, which means you need to take into consideration the direction. So at point A, velocity is going up. Okay, at point A, velocity is going up, which tells you this V is a positive V. At point B, your velocity is pointing downward. Okay, it's pointing downward. So in which it means, okay, this is a positive V. This would be a negative V. Okay, negative and positive. So now let us complete the calculation. So A average, okay, A average is equals to V final. V final is pointing downwards, therefore negative. Okay, negative 11 minus V initial. V initial is now a positive value, so just minus 11 divided by the time taken. So again, the time taken is 1.43 seconds. Okay, which then give you A average is equals to negative 15.38 meter per second squared. Okay, negative 15.38 meter per second squared. So negative value means it's going downwards now. All right, it's going downwards. All right, so now I give you this question is slightly more complicated. I give you 3 minutes. Okay, 3 minutes to write everything down and make sure you understand it. Why I use distance and why I use displacement in questions B. Okay, what is the difference between speed and velocity? So this chapter, this question, it has a lot on your concept in vectors and scalar quantity. See whether you understand what is the difference between scalar and vector. All right, when to use distance, when to use displacement, and so on. Okay, so 3 minutes for you to write it down. Okay, so if there's anything that you don't understand, make sure to ask, yeah? Because now we're still at the intro part. We haven't looked at the how to calculate centripetal force and so on yet. Yep. If no questions, let's move on to the next questions. Okay, so next question. Now this is a very simple question. So the radius of a Mercury circular orbit around the Sun is 5.79 times 10 to the power 7 kilometer. Okay, kilometer. So this is the radius. And the Mercury travels around these orbits in 88 days. So it travels around the orbit, which is a 1 revolutions in 88 days. Okay, so this is what happens in a 1 revolutions. Okay, travel around the orbits. So around the orbits means 1 revolutions. Calculate the linear speed of Mercury. So in order to calculate the linear speed, of course, you need the angular speed first, because now it's involved circular motions. Okay, so information that we have, okay, omega equals to theta over t. So we know that 1 revolution is 2 pi over, now 88 days, you want to convert it into second. So 1 day is how many hours? 24. Okay, so 1 hour is how many minutes? 60. 1 minute is how many seconds? 60. So that is how you do unit conversion. 88 times 24 times 60 times 60. So you will get, okay, I think it's 7.6 times 10 to the power of 6 seconds. Okay, times 10 to the power of 6 seconds. So this is the values. Okay, this is the value. Wait, yeah. Oh, sorry, no. It's 2 pi over, okay, 2 pi over 7.6 times 10 to the power of 6. Okay, so this one you calculate, because I don't have a calculator with me right now. See what is the answer in terms of radian per second. So now that you have the omega, you can then proceed to calculate the linear speed, where v equals to r omega. Okay, v equals to r omega, which is then equals to, okay, so r is 5.79 times 10 to the power of 7. Now in terms of km, so you want to change km into meter, you times another 10 to the power of 3. Okay, so times with the omega, which is 2 pi over 7.6 times 10 to the power of 6. Okay, then the final answer is 4.79 times 10 to the power of 4 meter per second. Okay, 4.79 times 10 to the power of 4 meter per second. So this question is just very simple. It just want to test whether you understand the questions or not, whether you know how to find omega or not. So omega plays a very, very important role in chapter 6. Make sure you know how to find omega. Okay, especially in terms of revolutions, and sometimes questions will give you in terms of degree and so on. So you need to know how to convert between them. Okay, between the degree and then revolutions and also radian. Okay, so this one family is very important in this chapter. So I give you 1 minute to write it down, and then we will proceed to the next subtopic. Okay, next subtopic, which is centripetal accelerations and also centripetal force. Okay, so far, any questions before we proceed to the next subtopic?
No, madam. No, madam.
Okay, very good. So I hope you guys understand. All right, next. Okay, so now this one involves applications already. A motorbike moving at a constant speed. So again, this is our V in a circular track of radius 25 meters. So we have R. Okay, calculate the centripetal accelerations of the motorbike. So questions one is very simple. You just apply the definition where A is equals to V squared over R. Okay, which is then equals to 20 square over 25, which should then equals to 16 meter per second square. And then the time taken for the motorbike to complete one revolutions. So again, the questions give you revolutions. Okay, so revolutions, it's very, very important in your syllabus. So one revolutions, again, it is equals to 2 pi radian. Okay, so the works, the phrase one revolution, it carries a hidden meaning. Okay, a hidden meaning that tells you now you have theta equals to 2 pi. Okay, so perkataan revolutions ini, one revolutions ini, dia membawa maksud hidden. Okay, yang memberitahu Anda that the theta is equals to 2 pi. So now what are we going to do? So we have a speed and then so we want to calculate time. And then if you look at the question, it gives you theta. Now, how are we going to link them together? Again, when you have V, most of the times you're going to use V equals to R omega. Okay, and then from omega, we can then insert theta. And of course, when you insert omega equals to theta over T, you can then find the time. Now, perfect. So which is R equals to theta over time. Okay, theta over time. So given V is 20, so 20 equals to R. Okay, R is a 25, sorry. So 25. And now my theta is equals to 2 pi. And then over capital letter T. Okay, capital letter T means this is the time taken for one revolution. So rearrange the equations. The period is then equals to 7.85 seconds. Okay, the time taken for it to complete one revolutions. Now, of course, these questions, if you want to use small letter T, also can. Okay, it doesn't matter. Just that I use capital letter T to make it clear that this is the time taken for one revolutions. All right. So very simple. 1 minute for you to write it down. Then we're going to proceed to a more complicated questions. Okay. All right, now these questions is a slightly more complicated because again, it has your concept. And also why I say it's difficult, because all three answers given here, they are wrong. Okay, so all three answers given here, they are all wrong. So now let's look at questions A. An object is placed on a rotating machine with radius 8 meters. If the angular displacement, now you are not given a value, but instead you are given an equations for theta, for angular displacement, and we will find out why very soon. Well, theta is measured in terms of radian. When t equals to 5 seconds, find the angular velocity. Now, if you look at this question, it doesn't tell you whether it wants an average velocity or instantaneous velocity. But then if you look at the question, it mentions at times t equals to 5 seconds at one particular moment. So which tells you this v that it wants is actually instantaneous. Okay, instantaneous value. So how to calculate instantaneous value? So which is v equals to d theta over dt. You need to differentiate theta. Okay, so d over dt bracket 0.3 t squared. How to differentiate? How to differentiate? That is a question. So now let's say if you have you want to differentiate, okay, d over dx, axn. You want to differentiate in terms of x. So what are you going to do? So you move the n to the front, okay, to multiply with a, and then this n you then put minus 1. Okay, so after you differentiate axn, you're going to get n times a, and then xn negative 1. Okay, n times a, xn negative 1. So this is what happened in this equation. Okay, so you move the 2 to the front, okay, to times with 0.3, and then 2 minus 1. Okay, the power will becomes 2 minus 1. So it is equals to 0.6t. Okay, because 2 times 0.3 give you 0.6. 2 minus 1 give you 1. Okay, but 1 you don't have to show it in the equations. All right, you don't have to show it in the formula. So that is your equations for velocity. And then you sub t equals to 5. Okay, which is equals to 0.6 times 5. Then you will get 3.0 radian per second. Okay, 3.0 radian per second. And then tangential linear velocity, v equals to, this one should be omega, sorry. Okay, wrong symbol. So v equals to r omega, which is then, given r is 8 times 3, which is 24 meter per second. Okay, 24 meter per second. And then the last one, centripetal acceleration. So a is equals to v square over r. Okay, v square over r. So v square, let me calculate first. Yeah, where is my... Okay, so 24... So 5, 6 divided by 8. Okay, so it is equals to 72. Okay, 72 ms negative 2. So v square is a 24 square. 24 square divided by 8, you will obtain 72 meter per second square. So these questions, okay, the purpose of this question is to show you how to do the differentiations when it involves instantaneous velocity. Okay, now next things, what I want you to do, okay, I want you to add one more questions. Okay, so that you can see the difference between instantaneous and also average. Okay, average angular velocity. So add one more questions, calculate average angular velocity. So how to calculate? Okay, if your object start from initial position. Okay, if your object is at a t equals to 0. Okay, start from t equals to 0. So let's see. In order to calculate average velocity, if you recall, the formula is omega equals to theta final minus theta initial over t final minus t initial. Okay, so we want to calculate theta. So let's say at t equals to 0, your theta initial is equals to, okay, so you basically you sub 0 into the equation. 0.3 times 0 squared, which is then equals to 0 radian. And then at t equals to 5 seconds, theta final is equals to 0.3 times 5 square, which is then equals to, I think it's a 7.5. Okay, 7.5 radian. Okay, you can then, okay, you can then, oops. Okay, you can then, okay, you can then sub it into the equations for the average. So omega average is then equals to 7.5 minus 0 divided by the time taken, which is 5 minus 0. Okay, and you obtain 1.5 radian per second. So this is if you calculate average angular velocity. So there is a slight difference between the instantaneous and average. Average, you need final and initial. And then instantaneous, you just look at what happened at a particular moment, at one moment. All right. So This one, I give you 3 minutes to write down, especially the one in terms of green color, so that you can do comparison between questions A and questions D to see what is the difference between average and also instantaneous. Okay, so 3 minutes from now for you to write it down. Then we'll proceed to the last questions, okay, for today's sections. All right. Yeah, I got a message coming in. So you guys continue first with a next question. See whether you can answer or not. Okay. Next one. Okay, so this question is slightly more complicated. Why? Because I would say involve more on the mathematics. Okay, you need to know the concept in a vector, how to sketch vector, how to use the parallelograms to find the changes in vector. Okay, now let's look at the questions. This is question number 3. The car initially traveling eastwards turns north by traveling in a circular path at a uniform speed as shown in figure 6.6. Okay, the length of an arc ABC is 235 meter. So this one, okay, this curve is a 235 meter. All right, so you're given S equals to 235 meter, and the car completes the turns. So it takes a 36 seconds to travel from A to C. Okay, it takes 36 seconds to travel from A to C. So how are we going to solve questions 8? The accelerations when the car is at B, okay, that is located at an angle of 35 degrees. So first of all, okay, if you want to calculate acceleration, it doesn't matter which equations that you're going to use, you are going to need R, okay? So let's say A equals to V squared over R. We don't have R, okay, but then we can calculate it by using the information given here. So you look at S, you look at T, okay, then try to think how are we going to calculate R. So other than S and T, there's one more information that we have. By looking at the diagram, from A to C, it gives you 90 degrees, right? So theta is 90 degrees, and at the same time, it is equals to pi radian. Aha! So now we have enough information to calculate radius. How? So by looking at theta and S, okay, we know that, let me write it here. S equals to R theta. So S given is 235 meters from A to C. R is an unknown, but now we do know that the theta is 90 degrees, which is pi. Okay, so from here we can determine the radius of the circle, where R is equals to 149 meters. Okay, so now that we have R equals to 149 meters, we want to calculate V. Okay, can we determine V? Well, let's see. Do we have enough information? Yes, we do. Okay, so V is equals to the change in S over the change in the time. Okay, let's say your object starts from A, where A is S equals to 0 until point C, your A is 149. So 149 minus 0 divided by 36 seconds minus 0. Okay, therefore you have V equals to 6.53 ms negative 1. Okay, so well, you might ask me, why can't you find the velocity at point 35 degree? Now, it doesn't matter, okay? Now, what are you looking at? You're calculating the average velocity, okay? An average velocity in a uniform circular motion is equals to your uniform velocity. Okay, uniform velocity. Oops. Okay, uniform velocity. Now, what does it mean by uniform velocity? It means every point, okay, every point along the circular path, okay, have a same speed. Okay, so the speed at every single point, it doesn't matter whether you start from point A or not, or you're at point B where that is 35 degrees, or point C. At every single positions, at every single point, your object is going to move with this same velocity, which is a 6.53 meter per second. Okay, so it doesn't matter what is the directions, what you're looking at right now. You want to know the value of the velocity, of the speed, the magnitude of the velocity at point B, which is your average velocity along the path. Okay, so this is only for circular motions. Average velocity is not always same as uniform velocity. But in our circular motion, in our syllabus, we assume our object is moving with constant speed. Therefore, we can make an assumption where average velocity is equals to uniform velocity, okay, for uniform circular motion. Uniform circular motion. Okay, it's more on the magnitude. Okay, we're focused more on the magnitude. So not the velocity, of course, it's the magnitude of the average velocity is equals to the magnitudes of the uniform velocity. So it's more on the speed. So A is equals to V squared over R, which is then equals to 6.53 squared over, okay, now radius is a 149, therefore it is equals to 0.286 ms negative 2. Okay, 0.286 ms negative 2. So that is questions A. Okay, questions A. Based on the diagram, based on the information given, we managed to determine R, we managed to determine V, and then we use the R and V to determine the acceleration. So questions B, the speed of the car, straight away you can say V is equals to 3 plus 6.53 ms negative 1. Now, of course, you have to show the calculations, yeah, in exam. You cannot just give the value. Or what you can do, you say refers to, okay, refers to A. Okay, refers to questions A. So from here, you can then get the value. Okay, can get the value. So by referring to questions A, V is equals to 6.53. Okay, so you cannot just leave it, okay, because in exam, we will mark it according to your label. So sometimes, okay, sometimes this is what happened in a real exam. Okay, students do a questions A. In questions A, they already obtained the answer for questions A, and then at the same time, they also have the answer for questions B. Okay, and then they straight away they skip to question C. Now in that case, we will assume you didn't answer questions B. Okay, because we will mark it, we'll check it according to your own label. So since here you just label A and C, you are not answering questions B, even though we know that B is in your second question, in your questions A, but we don't know whether you will use it for questions B or not. Okay, as examiner, we cannot make assumption. We cannot assume, okay, now this is definitely the answer for questions B. No, we cannot make assumption. Okay, so you yourself have to rewrite it here, B, and then write down the step, write down the value. If the step is too long, then you say the step refers to questions A, and then you give the answer V equals to 6.53. Then that is fine. Okay, then that is fine. But if no, okay, if not, then you have to show complete calculations again. All right. So you cannot just skip questions B like this. So make sure you show A, B, C, label it clearly. All right, without skipping any questions. Okay, oops. So now let's look at the questions C. So question C is a question C is a tricky questions. All right, why? Because it asks you to calculate the average accelerations during the times interval 36 seconds. So A equals to, okay, now you want to calculate average. All right, when it comes to average value, okay, what happened is we are going to need final minus initial. So let's say V minus U over change in the time, 36 seconds. How to calculate V minus U? Okay, you cannot simply take the value and subtract them because they are pointing towards different direction, the velocity. Okay, the velocity, they are pointing toward different direction. So you cannot simply subtract them. What you can do, you take the angles, you take the vector. Okay, you do it in terms of vector. So now you look at A. A is initial. Initial is going to the right. And then final is going up. Okay, final is going up. So what are we going to do? Now we want to take the vector out. We take it out, we place it here. So this is your U, which is going to the right. And then this is our V, which is going up. All right, which is going up. So we want to calculate the change in the vector, which means what we want is the line that is joining them together. You cannot calculate resultant though, because what we want is not resultant. We want the changes. Changes is always V. Okay, change in the V. But how are we going to calculate it? How are we going to calculate it? That would be the questions. In terms of vector, we cannot simply add them up. Why? Because my U and my V, they are not joining from a head to tail. Okay, so in vector, if you want to add them up, what we need is the head to tail vector. Okay, head for vector 1, joinings touch the tail of the second vector. So what are we going to do? We are going to flip U over. So you flip U from pointing to the right to pointing to the left. So now we have negative U. Okay, and then V, we keep it. Okay, V, we keep it, we don't change it. So what happened right now? Now the head of vector U is touching the tail of vector B. So now this is the correct vector. Okay, then we can calculate delta V, sorry. So how to calculate delta V? Now, when it comes to vector, you want to add these two vectors together. So V plus negative U. Okay, so it is our V minus U. So this is the values that we are going to use in our calculations here because we want V minus U. But how to calculate V minus U? Based on the shape, now this is a right angle triangle. Okay, so what we can do is delta V is then equals to square root v squared plus negative u squared. Okay, which is equals to, now we have a 6.53 squared plus negative 6.53 squared. Okay, we solve it by using vector method. So eventually you're going to obtain 9.23 ms negative 1. So this is delta V. Okay, this is delta V according to the diagrams given. So A average is then equals to 9.23 divided by 36 seconds, which then give you 0.256 meter per second squared. So how are we going to determine the directions? So just use theta. Theta equals to tangent negative 1. Okay, so a vertical component divided by a horizontal component, v over negative u. Okay, which then give you a tangent negative 1, 6.53 divided by negative 6.53. Okay, which is then equals to 45 degree. This 45 degree is located above negative x-axis. How do I know it's above negative x-axis? Because now I have a negative x component and then positive y component. So negative x, positive y give you second quadrant. Second quadrant, it tells you that it's above negative x-axis. Okay, above negative x-axis. That is the second quadrant. So this 45 degree is located at the second quadrant. Okay, so which then if you place this delta v, okay, now this vector delta v actually it has a meaning. Okay, this green color delta v. Now if you put this vector back into your diagram above, okay, well, average means we're going to take the center. So if you place it back above here, this one actually it represents the directions of AC. Okay, it represents the directions of AC. That's why we say accelerations in a circular motion, it is always pointing towards the center. Because when you take the vector, you put it back into the circle. Okay, average, you put it at the middles of A and C, at the midpoint of A and C. It shows you this vector, this delta V vector. Okay, it's always pointing towards the center. And this vector also represents the directions of centripetal acceleration. Okay, so it doesn't matter which points that you are taking, as long as you take initial and final from the same circle, you'll find that the delta V that you derive is always pointing towards the center. Okay, that's why we have centripetal acceleration, because delta V, we use it in accelerations equations, okay, in calculating the acceleration. All right, so I think that marks the end of today's class. You just write it down and then you may leave the class. Okay, you may leave the class after you write down everything.